Why, hello there, everyone. Welcome back to yet another TeachLA Learning Lab crash course. I'm your host, Leo. With me is Matt, the one and only. Today, what we're going to be talking about is testing, specifically testing in JavaScript. The things we're going to be talking about are why it's important, what it is, how you can do it, and also how we can do it in our own code base. Not just methodology, we're going to be focusing on application here. Specifically, we're going to be using Jest, which is a great little library. As always, if you want to take a look at the lesson plan for this video or any of the resources that we have included, you can take a look at our GitHub. There should be a link in the description to the README for this lesson, and that should be a good resource for you all. Okay, so let's just kind of jump right in, I suppose. First off, before I start writing actual code and before we start tinkering around here, let's answer this big question that might be over your head. What is testing, right? Well, testing is simply writing a collection of expected behavior for a particular function or a program or anything to that effect. So we could write tests for our components in React. We could write tests for our functions in a math library. As you can see here, I'm kind of starting on my own. Add 2, it's going to be revolutionary. And what that does for us as developers is it allows us to guarantee behavior of particular libraries and to ensure that changes don't break things. More specifically, when you have automated testing, whenever you implement a new feature, if we have tests that are written for it, then we know that it passes the behavior that we anticipate just by reading through the tests. When we're refactoring our code, when we're changing the way that things are written, it's good to have tests written because that way, if our tests fail when we change a particular name, for example, let's say I change add2 to add3. Well, then the tests that use add2 might break. Maybe there was some function that we forgot to rename, or maybe there was some class that used it that we forgot to rename the instance of in it, and as a result, it just broke everything. We would know if we had tests written that used add2 or add3 beforehand. Another great thing is when we update our function, maybe the implementation. So let's say I had some function that folds an array, fold right, for example. We would probably provide some other function here as well. If I had that function here, then if I wanted to change the internal implementation of it, but not the signature, meaning the part that we actually see as a developer, then if I had tests written, we would be able to change it safely and rest assured that as long as our code is passing the tests we had written beforehand, nothing is going to go wrong for any existing implementations. Of course, that's not a super airtight guarantee all the time because maybe you only wrote 3 tests, but it's still better than nothing. And then the last thing that we're going to be mentioning here is why it's important for deploying your code. More specifically for Netlify and GitHub, it's really nice because you can automate tests when you push to a branch or when you make a pull request or when you deploy to Netlify. And if you're failing tests, then what's going to happen is it won't deploy and nothing will get broken on the server, which is really important because you want to make sure that your users are none the wiser to any breaking changes in your code. Okay, so that was a lot of stuff that we just talked about, but I do have a few more things that I really quickly want to touch on before we kind of get into writing code, all right? So you may have noticed really quick that I mentioned something about why testing is important as a developer, right? Well, there's a whole other area of development or a whole philosophy to development, which is known as test-driven development. So you'll see this a lot in programming languages like Go. But the idea is that when you are writing a particular feature, when you want to implement something, first you write the tests. So that way you can describe the actual behavior that you anticipate out of your function or out of your class or out of any particular application, right? And when you write those tests, they will fail, right? You want to make sure that they fail because if they don't, then your tests are wrong. But after you write those tests, then that's when you start writing your code. And you write your code such that it fulfills the tests that you expect it to pass, right? Once it passes them, you know that your code is A-okay, and then you're okay to push it. This way, you're writing tests as you code, and you're making sure that your code is up to scuff with what you anticipate it should do. Very handy. So that's test-driven development. And then another thing before we dig into writing code is CI and CD. You'll see this in the README. What they mean are continuous integration and continuous deployment. Now, I will give a really quick brief flyover of this, as I'd like to keep us on time. But what they are is continuous integration has to do with the idea of keeping your code integrated in a pipeline to a service, right? So when you're deploying it to Netlify, for example, we can think of that as continuous deployment, right? Continuous integration is more so the process of making sure that along that pipeline, nothing bad is going to happen when we try to deploy it, right? But all that really boils down to is we automatically run tests when we push code. So now that I've boiled that down to a viscous substance of 5 words or something, let's talk really quick about how we can actually write some tests and what kind of tests there are. Okay, so for starters, I am going to go ahead and I'm going to write a function right here in my brand new math library called sample. It's revolutionary. And I'm going to call it divide by 3. Actually, let's make it something a little more interesting. Let's do add 5. And the reason I'm doing addition here is just so that way if we wanted to play around with it, we could pass a string in as n, and then we'd see 5 concatenated on as a string. Anyways, what we've done here is we've written a really quick function. All it does is return the value of n plus 5. Then it exports this via module.exports, which is kind of like a, it's the proper way of exporting a function in JavaScript. It just exposes the name to outside of it. And then what we're going to do is write some tests for it. And to start writing tests, we are going to need to install our testing library. And in this case, it's going to be, whoops, I should change directories to the one we're working on right now. It's going to be Jest. I turned on caps lock. We're going to save it as a dev dependency, meaning that it's not actually going to be something we need for building, because it isn't. We're using it for testing. Now, Jest is a great little library. What it does is it allows us to write very expressive tests that read very easily to a coder, that allows to describe the anticipated behavior for our function, our library, our class, what have you. So I'm going to go ahead and open up this test that definitely doesn't exist. Oh, that's app test. Whoops. Okay, cool. I haven't written the test quite yet. Nice. So what we're going to do is create a file, sample.test.js. And the reason that we've used this nomenclature is because .test.js is going to be the pattern that Jest is going to look for by default. You can, of course, change this and tell it to look for other files, other different or other extensions, but this is the default. We're going to roll with it. So the first thing we need to do in a test is include the file that we're concerned with. So what I've done here is I've just imported, let's say sample is the name of it. I've included the file sample, our library, our fake math library here, as sample. And then what we can do is call the function add 5 if we wanted to. But for our purposes, we're going to go ahead and write some tests. The way that we write a test with Jest is we first declare it by calling the function test, not test scheduler, test. And then within there, we provide it 2 arguments. First one being the name of the test or a description of what it's testing for. Add 5 works as expected, is what I'm going to say here. And then we pass it a function which contains the body of our test. You can think of it kind of like as the name followed by the description, right? And in the description, what we're going to write is a handful of wrappers provided by Jest, which are just simply functions that read fairly easily. So we're going to expect something. In this case, we're going to expect add 5 called on the value 5 dot to be 10. Pretty handy. Reads like normal English. This is why tests are pretty cool, especially Jest tests. They read very easily, in my opinion, compared to some other testing libraries. If you've ever written tests with C or just straight up assertions, you probably know what I'm talking about. They get kind of tricky. So we're looking at this right now, and we're expecting that the value of add 5 called on the value 5 should be 10. Now that we have our test written, all we got to do is run it. And we can do that very easily just by running npm test And this will automatically call Jest for us. Oh, whoops. Module not found. Oh. Am I currently on the wrong? No, I'm not. Okay, cool. Well, I'm going to reinstall Jest, I guess, see what happens. Not sure why it didn't pick up anything before. Maybe I'm doing something wrong. There we go. So now that we've run Jest, you'll see that it add5 is not defined. Oh, sample.add5. Excuse me. Filled with errors today. Okay, so what we've done here is I accidentally included it under the wrong
I think
name.
the module.exports just needs to have like an object destructure.
Yeah, no, I just did it by default, and then I just imported under the sample name. It's okay. Anyways, now that we've taken a look here, when we run Jest, you can see that it has a nice command line interface for us, which breaks down all the tests in each file and whether they passed or failed. If I were to write something that would fail, for example, add5 fake test, I will call it. Use proper capitalization today. I just give it a function that says we expect sample called on 5 to be like 11. Then we will see that it is reflected in our tests that indeed one passed and one failed. And you can see here that it expected the value of 11, which we declared here, but instead it received 10. Nice. All right, cool. So that's all fine and good, Leo. I see that you've written some basic tests for a math library that is ultimately of zero consequence. But why is this useful? That's an excellent question. Well, for our purposes, we've been working a lot in React, and we're writing React web apps. So how can we apply Jest, and how can we apply these JavaScript tests to React? Well, luckily for us, there's a great piece of software from the team at Airbnb, which is called Enzyme, that lets us do that. So let's really quick reflect on the introduction to React, the Hello World app. Now, you've probably seen this a handful of times at this point, but the basic idea is that we just have a giant container followed by a handful of elements talking about how you can edit React, and then something I've added on is a small little button with an on-click that is passed via the props of the app. Okay? The reason that I've passed it a function through the props is because I want to make this a testable component. I want to be able to test the on-click behavior. Now, why did I talk about Enzyme just a second ago? Well, Enzyme allows us to write tests for our React components, and it allows us to work with them in a very straightforward manner. Now, there is a stock testing library that's included with React, and it allows you to write tests such as this, in that you are allowed to basically find elements or find components within your component that are running particular pieces of text, or meet a certain class, or have a certain class name, or have a certain ID. And then you can use the same kind of syntax as you would in Jest, and you can say that you expect, say, a link element to be in the document. Now with Enzyme, syntax is similar, although it varies in a few small respects. So what we're going to do first is actually install it. So first I'm going to actually change directories back out. I'm going to go to the Hello World app, and then I'm going to run npm install, because there's actually no node modules folder in here right now. So it's going to really quick just install the dependencies that it needs. And then after that, we're going to install Enzyme. And from there, we will write a basic test. In the meantime, I'll really quick explain what this test is doing. So first, it calls render on our app component, which we've imported. And what it does is it pulls out via a object destructure the function getByText. So render, what it does is it provides an object with a lot of properties that we can use to determine whether particular elements are within the actual component or whether other things are present. But in this case, we pulled out only a single function, which we use to find whether the phrase learn React is actually in a component within our rendered app component. And then what we say is we expect that this element, in this case, we're looking for the link right here, to be within our document. So that's the basic test structure using the default library. Now, that's still running, but I'm going to just kind of get right into it. What Enzyme allows us to do, let's just say import Enzyme for now, and then I'll add in the functions we want. What Enzyme allows us to do is, instead of doing renders such as this, it allows us to do a variant of them, which are shallow renders. And what that means is it allows us to isolate our particular components and only worry about things at the shallow level. It doesn't render every single component upon which a single one depends. It allows us to test the specific behavior of our single component and avoid running into issues that we might see if we were rendering the entire thing as a deep render. So, pretty easily, what we got to do is install Enzyme, which should happen after this. It's taking a while today. But in the meantime, what we're going to have to do is actually set up Enzyme. Now, I've already got the code in here, but in your setup test file in src, or source, you'll have a brief opportunity to set up the testing libraries that you use before Jest actually does anything. So you can see here that the default React library actually brings in right here just a random import for us, basically extending the expect function to allow us to do the things that Enzyme will let us do. And over here, what we're going to do is actually use Enzyme and configure it. Now, Enzyme as a library still has the need for something called an adapter, so that way it works with the version of React that you're working with. Now, the one that we're working with in this particular web app is React version 16, so we have to install the proper, we also have to install the dependency Enzyme adapter React 16, in addition to just installing Enzyme. From there, all we have to do is make a call to the configure function, which we pull out from this import, and provide it the value of a new adapter, being a new React 16 adapter, as its adapter. And then from there, we can actually get down to writing tests. This is installing Enzyme as well, by the way, so again, not sure why this is taking so long. Okay, so let's actually write a test, why don't we? First thing we're going to do is import that shallow render that I talked about. So instead of render, we're going to just import shallow from Enzyme, like that. Now what shallow allows us to do is mount a component, but only the component, and then figure out various properties about it, and it'll provide a wrapper for us. And instead of using the test function, as we have been, instead we're going to use describe. The reason that I'm going to use describe here is because it lends itself a little bit more nicely to talking about components, because we're not talking about, we're not testing a single function, right? We're not running a unit test, which I actually neglected to mention at the start of this. I'll talk about that in a bit. Instead, what we're doing is describing the holistic component. Great. And then within each of these descriptions, we can provide a variant of test, which is it. And in there, we say what it should do. So within app, we expect that app should, or it, should be able to render our button, for example, right? And in this case, we provide a function as always. Then once we've provided our function, we're going to create a wrapper within it. And that wrapper is going to be declared as the result of mounting our app component with shallow. Now, what this does is it returns an Enzyme wrapper, which is very handy, and it makes writing tests for React components very easy. And then from there, we can use our standard Jest syntax to start working with the wrapper. So something that the wrapper allows us to do is test and see if a particular component or a particular element exists within that component. And all we got to do is just call exists on it. And then from there, we can provide any kind of selector. That could be the name of a element type. It could be the name, so it could be the name of an HTML tag. It could be a class name. It could also be, an ID. So for our purposes, I want to make sure that the button is actually rendered. And we're done installing, which is nice. So what I'm going to do is just provide the button selector. It's just like CSS. Then from there, if we should be expecting that it exists to be true. What we're saying here is we anticipate that if our component is working properly, the button right here will actually be rendered. Now, this is a very simple test. It's a very simple unit test, and this is something that you'll probably find called a smoke test. Smoke tests are very common for these things, just making sure it works. So let's go ahead and run our basic tests right now, just to make sure that everything is a-okay. Okay, so you can see here that Jest is letting us know how long it expects all these tests to take, what it needs to do. And there we go. As anticipated, our very simple test, renders learn react link, works as anticipated. And our description of app, as you can see right here, meets the criteria that we specify, being it renders our button. Very handy. And you can see here that when we ran npm test, thanks to CRA, create react app, there were a few things it did for us, one of which being it gave us the ability to watch our tests. So if we wanted to make sure, if we wanted to modify our code live and see if we can modify it to fix a test that it wasn't passing, then we could do that just by having it in watch mode in the other window or on a terminal, and then go from there. So that's one of the basic use cases of Enzyme. But there are some other useful things that we might want to do when we're testing in React. Hey, Matt, what's something we might want to do if we're testing React components?
That's a really good question. You know, you mentioned you have a link, right? Could we check if we click on a link or a button? Is that something we could do? That seems like it'd be useful.
Yeah, you know, that actually, you know, great point, Matt. That seems like something we totally should be able to do. And indeed we can, thanks to Enzyme. So we're going to add on a little thing here to our description of the app component. We're going to say it responds to clicks. Nice. So what I'm going to do here is provide another arrow function, and I'm going to create the wrapper as usual, but this time I'm going to put a little spin on things. Recall, if you see here in our right editor, that we actually accounted for the fact that we might want to pass down an on-click element or an on-click prop to our button when we're creating our component, when we're mounting it. So what we're going to do here is we're also going to pass it down we're also going to pass it down an on-click function. I am just going to make a simple little function that increments a variable that is in our scope. So let's declare a variable I, called 0. And now we have a function here that on click will increment the variable I so that it is 1 or over 1. Great. So I'm going to go ahead and keep this off to the side for us all. Now from here, we can actually do some pretty intricate things. Thanks to Enzyme, we can target specific items within a component. So you can see here, we've already got a bunch of suggestions from the IntelliSense server. I'm going to go ahead and use the find function. What I'm going to do is find another selector. Like we mentioned earlier, any CSS selector will be valid here. And I'm going to try and find the button component. And then what I'm going to do is simulate. I'm going to simulate an event. Now, if you recall, there are a number of events that you can actually bind event listeners to in JavaScript. In this case, we're using onClick, but you could also do things like, you know, on enter, on mouse leave, things of that nature. So in this case, what we're doing is we're simulating a single click onto the button, and then we can use expect as usual, and we can say that we expect our incremented variable I to be 1 because we clicked it once. So let's go ahead and try running our tests again. Notice, by the way, that we've been writing these tests without needing to open up the application in our web browser at all. It's actually pretty handy. Also, I am OCD, I'm going to add that little semicolon. And since we're on watch mode, it's going to update. Nice. And then once these tests wrap up, I'll talk about a few more things of theory and go from there. So you can see right here, the longest test was rendering the learn react link. That's mostly because we're doing a deep render here. And I'm going to just remove that test altogether. Excellent. So now that we've kind of seen a few of the tests that we can do with Enzyme, some of the functionality it provides us, what we can go ahead and do let's talk about a few other things that are a little bit more generalized, a little bit more theoretical, I suppose. So, for starters, dependency injection. This is something that you'll hear thrown around when you're talking about testing from time to time, but it's the idea that we mock up a dependency of another component or another class. So I'll give you guys a quick little code example. Let's go ahead over to our example node. We'll put it in example.js. So let's say I have a class. I'm going to call it my class. And when I construct it, I want it to take a log, and I want it to set this logger equal to log. Pretty simple. And then in my example in the README, I think I did something with ternary, where I basically said if the log wasn't provided, then just make a console logger. So I provided a console logger here. And then the reason that I've done this, right, as this example, is that if I wanted to test my class component, and I wanted to make sure that when it has, when you call some function on it that causes it to log, then I could actually test and see that the log output is something that we anticipated to be, right? So I won't give something super concrete here. I just wanted to use this class as an example for the point we're getting at, which is that you should be able to inject via your tests dependencies such as a console logger. So that way you can pick up on the output and actually make your class testable. Okay, great. And that kind of leads us nicely into the last point that I'll really briefly touch on. Obviously, when you're writing your code, you should be bearing in mind that writing tests is best practice and that your code should be testable, right? So when you're writing a definition for a function, when I'm writing the signature for add5, right, I want to make sure that this variable right here isn't passed down through some very intricate hidden type, right? I want to make sure that it's just easy to pass in. You can inject a dependency very easily. You can test it very easily, right? I want to make sure that my code is easy enough to test. I want to make sure that my buttons allow you to pass in your own custom on-click function if you want to. Because if I don't, then it would be a very different story testing to see if the click actually worked, right? So I'm going to say that that wraps it up here. I went a little over time. Sorry about that. As always, all of the information that I just spewed out is in the README. All the code that I wrote here, although you won't find add5 in there, is in the repository. All of those links will be in the description. If you have any comments, please leave them. We will answer them.
Leo, I got a quick question for you.
Yeah, Matt, what's up?
Go over it, in this video, but I'm curious. There's like state and like hooks and stuff. Can you test that with Enzyme too?
Yes, you can actually. You can test things regarding. You can actually get the state of a particular component from your wrapper. So actually, let me.
We don't have to go into it now. We don't have to go into it. It's just, now that I know the possibilities there, that's great. And what about asynchronous functions? Can I test those as well?
Indeed, you can. Again, recall the concept of dependency injection. And also with asynchronous, you can, since you're writing tests, you can usually just await them. But in the case of talking about dependency injection, let's say that you had some asynchronous call out to a server, right? Then if you wrote your code properly, you could make it very easy to write a test that changes that endpoint or changes that call to one that you mocked up yourself. And in that case, you would be able to detect almost immediately whether or not that functionality is working, right? So let's say that this button was in fact actually doing a very complicated task. Right? What's that, Matt?
I was just gonna say that's super cool.
Yeah, Enzyme is super cool. Tests. Airbnb is nuts. So if I wrote some complicated function, let's say I made some fetch, right, out to some other thing, right? Like I made a fetch to, well, for sake of testing, right? Let's say I made it to a fetch URL, right? Then what I could do is pass in some options like a method. Let's make it a post, right? Recall this is from our lesson on networking and using fetch, and also asynchronous, because we're incorporating promises here. And I could also add in some body, right? I could say like a is equal to 2. I just like doing that. Great, then we could promise chain it. The idea here is that if we pass down the URL that we're expecting to use via props.fetch URL, we could test it incredibly easily. And we could mock up that particular URL on our own end. So that way we can pick up the test, right?
Wow, that's so exciting, Leah. I'm so excited to get started writing tests. One last question. You know, I don't know anything about tests. Do I have to add all the tests at once? That seems like a lot of work. Is it okay for me to add tests piece by piece?
Of course not, Matt. You don't have to write all the tests up front. Of course, test-driven development, they may say otherwise. They may like you to write a lot of tests, but for our purposes and for most purposes, you will only need to write a handful of tests and write them incrementally. You want to write a test that actually tackles a very small piece of functionality, like renders a button, before you end up writing some more complicated ones like responds to clicks, and before you end up writing even more complicated ones like responds or sends request, right? The idea is that when you're developing, you're doing so incrementally. So that way, when you have a break in your code, it's a very small break. And when you have tests written alongside it, you know exactly where that break occurred. That's the beauty of it.
Wow. I'm learning so much today in this, this last crash course.
Indeed, this is the last crash course, isn't it?
Yeah.
Is that right?
I think the Firebase one is chronologically last, but yeah, whatever.
Well, this is the last one that we did live, unfortunately. Thank you for joining us on this wild adventure.
Yeah, and one last thing I'll say is if you're watching at home and you're not part of Learning Labs, you're like, who the hell are these two people? Why are they telling us about coding? This was just an experiment for us to see how we can do online software dev training. If you made it through this far, you definitely have a lot of grit. But we would love to hear from you on what you didn't like and what you liked about this style, because we're going to keep on iterating. We want to make sure that this kind of content is accessible for everybody and that everyone is empowered and knows how to do things like making their own website or writing tests for their website or making a backend. So if that is the case, leave a comment. You can send us emails. You can find our GitHubs, all that kind of stuff. But yeah, and Leo, I'll leave it to you to close it off.
Sure. Just to reiterate what Matt said, yeah, thank you for joining us. If you want to get involved on this, or if you want to just rant to us, please hit us up. Our links and our information are on GitHub, on the repo, and we're also on the TeachLA website, which I'm sure there will be a link to either in this video or in the Firebase one. One way or another, again, this was a lot of material. If you made it through here, seriously, salute, yeah. But aside from that, I think that does it, yeah? All right.
Sounds good.
Take it easy, everyone. Thanks for joining us. Later. And I'll.
Oh my.